Okay, everyone, it's 12:30, so I'm gonna start this lecture. Before I start, any of you have any questions? Okay, so I posted your homework 8, and I wrote multiple versions because, as I mentioned in the last class, some students were solving the homeworks together. Basically, they were doing collusion that, as I mentioned during the beginning of the semester, is a form of academic dishonesty. So to prevent that, I just wrote multiple versions. So instead of having 20 questions, each 1 point, you have 10 questions, each 2 points. So just plan accordingly. Don't put it the last second or like last minutes. And you have like multiple days. You have today, you had yesterday, today, tomorrow, like Wednesday. So plan accordingly. Any questions? Good? Okay, so I'm going to continue with chapter 5. I'm not going to finish chapter 5 because we have so many different namings. First, last session we talked about ionic compounds. This session I'm going to practice them, talk about molecular compounds, and I'm going to talk about acids next class. So if you follow my instructions, I believe this would be most efficient for you to learn because I pace naming different compounds. In that way, you don't have to memorize so many naming in one session. And the other thing is that from now on, the lectures would be more dense, and we will be having like more things to memorize, more problems to solve, more calculations. So from now on, if you weren't studying after each class, I highly encourage you to do so because you would struggle in the class if you don't. Any questions about that? Okay, so now I'm going to continue with naming some elements and also mentioning, asking you to remember them. And if you did previously, now in this chapter, you see that it will help you a lot. Now, this session, we're going to talk about fluorine, chlorine, bromine, and iodine. And I asked you to remember these. So these are elements are in your group 7A. Can anyone tell me what is this group name? Yes? Halogens. Exactly. So remember that these are your halogens. And if they want to form a bond with a metal, what type of compound would that be? Ionic, right? So if you have like metals or a metal plus a halogen, you will be having an ionic compound. So if these halogens form an ion, first of all, what do we call that specific ion? Would it be a cation? Would it be an anion? Would it be a polyatomic ion? What would that be? So what are halogens? Are they metals, nonmetals, or metalloids? Nonmetals, right? So they gain electron. And specifically for halogens, they are in group 7A, right? So they gain 1 electron. So halogens, I guess I write this here. They gain 1 electron and they form an anion. Okay? So if we want to write them, I write F minus, right? They gain 1 electron. Or Cl minus, Br minus, I minus. So fluorine, chlorine, bromine, iodine. Remember them. And if they form an anion, they would gain 1 electron. Any questions? And again, as I said, I always include this periodic table because it reminds you of which elements are metals, which elements are non-metals, and which are metalloids. So I always include this slide so you can kind of like refresh your memory about it. And also the name of different groups. I'm going to keep asking you which of the following is an alkali metal, which one is an alkaline earth, which one is a halogen, which one is not a noble gas, you know. So remember specifically these groups that have group names. And can anyone tell me what would be the charge of alkali metals if they lose electrons and they form an ionic compound? How many electrons lithium would lose? Exactly. So you'll be having like Li lithium plus, Na plus, K plus, Rb plus, Cs plus, and so on, right? And when you want to name these cations, you just name the same metal. So you don't change the name. You say lithium ion, or like lithium cation, sodium, potassium, rubidium, cesium. Okay? And these were the ones that they only had one type of charge, right? And then alkaline earth metals, they would lose 2 electrons because they are in group 2A. So you just can't remember that like that. So these are group 1A, they lose 1 electron. These guys lose 2 electrons. And if not, I'm going to continue. Okay, if you with polyatomic ions. And I asked you several questions in your homeworks. I say which of the following polyatomic ion names is not correct, or which of the following is a polyatomic ion, or which of the following is not a polyatomic cation. So remember, in order to have an ion, you should have negative charge. So the ones that they have negative charges here, maybe I can zoom this a little. Okay, so here 2 minus, it means that CO3 has gained 2 electrons. And then these charge correspond to all the atoms in the polyatomic ion. Or here, NH4 plus, this is a cation. Remember, this is a cation. So if I ask you which of the following is not a polyatomic anion, and I give you NH4 plus is not a polyatomic anion, is a polyatomic cation. Or I ask you which of the following is not a polyatomic ion. And I give you nitrite, nitrate, nitride. Which one? Nitride, right? Remember. So this was N3 minus. Remember? Because nitrogen is a nonmetal, it gains electron. Because it's in group 5A, it gains 3 electrons to reach 8 electrons in its valence shell. Any questions? As I mentioned, I expect you to go through this table and read the names, especially for your homework, because you have to. I asked you, which of the following is not a polyatomic ion. You should know, kind of be familiar with the names. But I'm going to give you this table in your exam. But you should be able to work with it. Does that make sense? It's kind of like searching information through internet, right? So technically, everyone should be able to find all the information in the internet, but there are like certain websites that people should refer to, or depending on what you're looking for, there are different tricks to guide you to the information. So this is kind of similar. So I'll give you the table in the exam. All of you have it, but not all of you can answer the questions, because you should be able to work with the table and practice at home before exam. Okay. If no question, PowerPoint slides in front of you. And then you refer here, and then you find nitrate, which is like NO3 minus, right? I guess here I'm going to continue reviewing what I taught previously. So Can anyone tell me what is nitrogen? Which category of these ones? Atomic element, molecular compound, ionic compound. What is nitrogen? So how many say atomic element? How many say molecular element? So remember we had like atomic elements, we had molecular elements, right? And I didn't include the slide in this. I apologize to people who are listening to this at home because of the background. So I didn't include the picture again, but if I can manage to make this work, okay. I'm going to show you the table in your book. You see elements that occur as diatomic molecules and also the molecules that I highlighted as yellow here. You see hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. You see? So these are your molecular elements. So if I ask you what is nitrogen, you see it would be molecular element, or oxygen, fluorine, chlorine. So basically your halogens here, fluorine, chlorine, bromine, iodine, and this is where it's useful for you to know halogens. So you know automatically these are, like if I say fluorine, you know that it's a fluorine molecule. You don't have just like one fluorine atom by itself. I mean, you might have in laboratory, but in that scientists like forcefully have like one nitrogen atom. But in general, in nature, we have diatomic molecules of nitrogen. Does that make sense? And which one of these, now that I'm in this page, which one of these were atomic elements? Or can you give me an example? Noble gases, right? Helium, neon, argon, krypton, xenon, radon. So these are atomic elements. So you won't be having He2, right? It's just only one helium atom. Does that make sense? So if I ask you, what is hydrogen? What is the answer? Yes?
It's a molecular element.
Exactly. So hydrogen, again, was in that table that we just mentioned, right? Remember, hydrogen, oxygen, nitrogen, and your halogens. Okay? So what about CO2? What is CO2? Yes?
Molecular compound.
Exactly. So since you have more than one element, you have carbon and oxygen, it would be a compound. Since both of the elements are nonmetals, it would be molecular compound. What about MgCl2? Which one of these it is?
Ionic compound.
Exactly. So I'm going to write here. So this is molecular compound. This is ionic compound. So now, notes and parts. If I give you MgCl2 and I say what MgCl2 consists of, what do you tell me?
Magnesium and chlorine.
Okay, yes. But remember that ionic compounds compose of cations and anions, okay? So these magnesium and chlorine atoms have charges. So what is the charge of magnesium? What is it? 2+, right? We just mentioned that they are like in group, magnesium is in group 2A, so it has like the charge of 2, so it loses 2 electrons. What about chlorine? -1, right? We just said halogens are in group 7A, so they gain 1 electron. So what about Fe2O3? What are ions that consist, or what are the ions in Fe2O3? What is it? Iron, yes. Oxygen, but what are their charges? Yes?
Oxygen 2 minus and iron plus 3.
Exactly. And oxygen, I asked you guys to remember, and I have it in the next slide that I'm going to show you. So oxygen is in group 6A, so it gains 2 electrons. You should know this, right? And you have 2 ways to know, or like I guess 3 ways to know the charge of iron in this compound. The first way is to kind of memorize the table of metals that form more than one type of charge, but as I told you, you don't have to do that. So if you know oxygen has charge of 2 minus, you know that this compound should have overall charge of 0, right? Because overall, here you remember that for polyatomic ions, you have like the charge denoted on top right? So compounds in general are neutral. So they don't have charge. If you have like table salt and then you put it on the table, it doesn't have any charge. So it's composed of Na plus and Cl minus, but in general, the compound as itself, it doesn't have any charge, right? Everyone agrees with me? So you can say you have 2 Fe atoms, iron, right, plus 3 oxygen atoms. And the overall charge is 0. And I told you to remember that the charge of oxygen is 2 minus. So if you substitute here minus 2 for oxygen, it would be 2 Fe minus 6. So 3 multiplied by minus 2 is minus 6, right? Equals 0. So 2 Fe equals 6. So Fe equals 6 divided by 2, which is 3, which when we write just numbers without positive or negative signs, positive, right? So you know that, okay, this Fe should be 3 plus. Okay? Any questions? So this is one way. The other way is that usually we just switch the charges. So if I have like Fe3 plus and O2 minus, and I want to write a compound between Fe3 plus and O2 minus, I just put this charge here and this charge here. So it would be Fe2O3. So here, you know that this 2 was before charge of oxygen, and this 3 has been charge of Fe. And you know metals have positive charges, non-metals have negative charges. Does that make sense? But if you do this method over here, you should be careful, because sometimes the 2 numbers can cancel each other, like the example FeO that I gave you in the previous class. So if you write FeO, you know that oxygen is 2 minus. So you know that, okay, if this 2 was here before and now it's not, it means that a 2 was also here. So it was like Fe2 plus, and 2 and 2 cancel out. Does that make sense? Any questions? Yes.
So for the compound like this, with a plus, or would it be like in front of the minus? It's like with the positive charge coming before the negative charge all the time?
So yes, we usually, I guess almost always, we write metal first in ionic compounds and then non-metal, Great question. Any other questions? Okay. The here, like the complete list. So you should remember that group 1A, they lose 1 electrons, group 2A, they lose 2 electrons, group 3A, that you have aluminum, it loses 3 electrons, zinc loses 2 electrons, and silver loses 1 electron. And these are fixed, or metals whose charge is invariant from one compound to another. You don't have a zinc atom that loses 3 electrons. It's always zinc 2+. Okay? And these ones I expect you to remember. Okay? Any questions? So here, as I mentioned, remember the metals that have like only one type of charge, and don't, get tricked that here we have like also transition metals, zinc and silver, that they only have one type of charge. Sometimes it might be tempting that saying that zinc, since it's a transition metal, it has like variant charges. That's not the case. For zinc and silver, we only have one type of charge. Homeworks you have, so I have. And here are the list of metals that have like multiple charges. Didn't mean to do this. Okay. They have like multiple charges, and as I said, I don't expect you to know these charges. I won't ask you what are the charges of copper, but I give you elements, and like the previous example, iron 2 oxide or like iron 3 oxide, based on oxide, you should be able to calculate charge of iron, okay? And also you should know that some of these elements like tin and lead are not transition metals, but still they have multiple charges. Okay? Any questions? And for the book, but actually we might. So if you have like, for instance, you can have SN4+, right? So if I have like SN4+ and oxygen 2-, again, if we switch this, it would be like SnO2. So you should just be careful about the instances that you may simplify the numbers. But this method is pretty universal. But the least common denominator is the most robust method because it takes care of this issue. Great question. Any other questions? So if I ask you what is the name of this compound, what would you tell me? Anyone? So if you write tin oxide, you're on the right track. But remember, I asked you which tin. Can anyone tell me which tin? 4, right? And the reason it's not 2 is that you should remember that oxygen is always O2-, right? So Sn plus 2, right? 2 atoms of oxygen, and each of them have charge of -2 equals 0. So Sn minus 4 equals 0, so Sn equals 4. So it would be tin 4 oxide for that matter. Okay? So remember that if you have one of these metals, you should also specify the charge in Roman numerals in parentheses. Okay? Are we good? And also the other thing, when we have like non-metals and then we want to write the name of anion, we write the base name of the non-metal plus IDE. So fluoride, chloride, bromide, iodide, oxide, sulfide, nitride. And then especially for these guys, don't confuse them with polyatomic ions. We have also nitrite and nitrate in polyatomic ions, or like sulfite and sulfate. So remember, when you have IDE, you have only one element and the corresponding charges. Okay, any questions? Everyone's following me? The table. Going back much. Oh. And finally, naming ionic compounds, we said that we write the name of the cation, base name of anion, or like base name of the anion, or like the nonmetal, plus IDE. And as I said, if you remember one example, you can just like write it for all of them. Like sodium chloride, right? Sodium chloride. So this is an ionic compound, and you have like name of metal, or like name of cation, base name of nonmetal, plus IDE. Okay? So what is name of MgBr2? Magnesium bromide, right? You like here class. Okay. And similarly, if we have binary ionic compounds that they contain metal that forms more than one type of cation, the procedure is like the previous slide, but you also write the charge of cation with Roman numerals in parentheses. So kind of like iron 2 oxide. So this is like the only step extra. Any questions? Okay, so let me give you some examples. As you I give here using this to write a formula for the compound that forms from calcium and nitrate ions. So nitrate, I give you the polyatomic ion, and you should be able to identify nitrate, and don't confuse that with nitrite or like nitrite or other ions. And then I expect you to write calcium yourself. So what is calcium ion? Ca what? You should also write the charge, right? Calcium is in group 2A, so the charge would be 2 plus. Okay? And as I said, the easiest way is to write Ca 2 plus NO3 minus and kind of like put these two here, but you should write a parenthesis, right? Here, because these two belongs to all NO3. And also, before I erase that, this you had like 1 minus here, so you put 1 here, and you delete the charges. And we can also not write 1. If you don't write 1, it's implied that you have 1 calcium for every 2 NO3. Or the other way is that you know that you should write Ca and NO3 together in a compound. So you know that you have like 2 positive charges for calcium, right? And as we said, the compound should be neutral. So since each NO3 has a charge of -1, you should have in general 2 of -1. So you should have like 2 of NO3 for this compound to be neutral. Does that make sense? Any questions? Yes.
Sorry, I think I'm a bit confused at this part. Would you mind going over that process of getting to that?
Yeah, exactly. Yeah. So we were asked to write, let me just do this again. So the question asks us that write an ionic compound that forms between calcium and nitrate. Okay. So the first thing that you do is that you write the individual ions, right? So calcium, so the atomic symbol is Ca, and it belongs to group 2A, right? So the charge would be 2+. It's one of the metals that has only one type of charge. Nitrate, you write nitrate. Okay, so now you want to write a compound that composed of Ca2+ and NO3-, right? And you treat NO3- as if it's just one atom. So it's like a unit of, so it's a polyatomic ion. You know, treat all these atoms as if they are united. So this is kind of similar if you had like Ca2+ and Cl-. You only have one charge, and all of these, you know, are like one unit. Okay, so remember that. And the compound, you want to have overall charge of 0, right? Because as we said, you know, ionic compounds or like molecular compounds, they don't have any charge unless the problem statement tells you and you have like a specific compound. But in general, you know, our ionic compound doesn't have any charge. So now you want to write like a compound between Ca and NO3-. So if I have one Ca+, right? So if I write my compound somehow that I have one calcium cation, right? So if I have one Ca, okay, I want to see, and you can just like consider 2 CH2 and then things cancel out, you know, and I can, you know, solve that with like 2 CH2 and then you see that what I mean, that things cancel out. But as of right now, imagine I have to have one calcium ion, right? And as I said, treat all this NO3 as one unit. So I want to see, I just put it as like, I don't know, X, as something unknown. I want to see how many of NO3 I must have in order to have 0 charge overall. Okay? Does that make sense? And I'm trying to find how I'm dealing with the charge, right? So I guess, you know, for like Ca and NO3, I just substitute the charge of each of them. Okay? So the charge of Ca is +2. And I guess I can just cross it out. So this is +2, right? Or 2+. And this NO3, the charge is -1, right? So 1 multiplied by +2 is 2 minus x, right? This is like -x, right? Multiplied by plus again would be equals 2. So x equals 2. It means I should have 2 NO3- in my ionic compound, right? So if I have one Ca, I should have 2 NO3. And you can just write the formula as this, or we can simply not write 1 here, because when we don't write 1, it's implied that this is 1. So this is one way. The other way is that you just write Ca2 plus NO3 minus, and then, as I said, you know, treat this as like a whole unit. And then you say that, okay, here I have -1, so you put like the number 1 here, and then these 2 plus, you write 2 here. So it would be CaNO3 2. So the trick is that just remember that you want to have overall charge of 0. So here, the charge of calcium is +2. The charge of NO3 is -1. So you should have 2 of that. That 2 multiplied by -1 would be -2. So -2 and +2 cancel each other. And then when we add them together, it would be 0. Does that make sense? Good? Okay, let's do another example. So if let me now tell you, write a formula for the ionic compound that forms from aluminum and oxygen. So aluminum was among the cations, or like among the metals that would only form one type of cation. Can anyone tell me what was it?
+3.
Exactly. Right? You can write 3 plus or plus 3, both are correct. What about oxygen?
-2.
Exactly. So again, one way is that you write these guys and then put these 2 here, these 3 here. So your compound would be IL2 or like Al2O3. The other way is that you write the least common denominator for 2 and 3, which is 6. So you should have 6. So you should have, if you have like Al3 plus O2 minus, the least common denominator is like 6. You divide 6 by plus 3 would be 2, and divide 6 by 2 minus would be 3. In other words, you want to have 6 positive charge, 6 negative charge. So you already have 3 positive charges. In order to have like 6 positive charges, you should have 2 of aluminum, right? Are you following me? Because 2 multiplied by plus 3 equals plus 6, right? And for oxygen, you want to have 6 minus. So in order to have, you should divide minus 6 by 2 to have 3. So you should have 3 of oxygen. 3 multiplied by minus 2 would be minus 6. So in that way, if you have plus 6 minus 6, you would have 0, which is like neutral compound. Or as I mentioned, you can just like switch these charges to the number of atoms here. And that automatically takes care of the charges. Yes?
Are both of these methods the one where you switch the numbers down as well as the common denominator? Is that pretty universal? You can just use that for most
So
systems?
it is universal, but you should be careful, as I mentioned, for instance, FeO. Because sometimes this doesn't mean that each of them had like charges of like +1 and -1, right? So they had like charges of +2 and -2, and then you switch them, wrote them here, and then they canceled out. So you should be just careful about that. Or sometimes, I don't think we encounter. So okay. So this is actually our today's lecture that I'm kind of like starting late, but I feel like, we needed like more practice, and I encourage you to go to your SI Pass leaders. And I also have like a question asking you guys in your attendance at the end of the class that if you are fine with me knowing you're going to SI Pass for extra credit, I would gladly, assign extra credits for SI Pass. So the nature of SI Pass before was anonymous, and I talked with the person in charge of SI Pass, and I told them that I want to assign extra credits to my students, so they agreed that if students are fine with SI Pass not being anonymous, and I know who's going, I can assign extra credits for that. So depending on the results, yes.
Okay, make up like credit points for going previously or no?
I should talk with my SI Pass leader. So if I assume they don't have like a record of students going there because it was anonymous before, I should talk with them. But if we can,
I know like we signed in before we go,
Oh, okay. Did they? Okay, so if yes, yeah, I'll gladly do that. Yeah. Yeah, I thought because it's anonymous, I thought it's, so I guess it was anonymous to me only, so everyone else knew, just not me. I mean, I knew some students would tell me that they go to SI, but I wasn't aware. I thought it's supposed to be anonymous. That is kind of funny. So anyway, yes, so if that's the case, yeah, I gladly do that. Okay, so now for naming molecular compounds, and I asked you guys to, when you go home, study these, because next session I'm going to talk about acids, and it would be lots of naming. So if we paste it, it would be like easier. So like ionic compounds that I asked you to just remember sodium chloride, the name of the metal, base name of non-metal plus IDE. As long as you know sodium chloride is an ionic compound, you can kind of name other ionic compounds as well. Now for molecular compounds, I asked you to remember CO2, which is carbon dioxide, right? And some of you might have heard of carbon dioxide. So what we do in naming molecular compounds is that we write a prefix, name of first element, prefix, base name of second element plus IDE. Okay? And the only exception is that if you have mono, or if you have like one element at the beginning, you don't write mono. So you don't write mono carbon dioxide or like mono carbon monoxide. You only write carbon dioxide. But other than that, you write the prefix, name of first element, prefix plus base name of second element plus IDE. And these, prefixes, right, you should remember. So mono is 1, and I think that is kind of straightforward. Mono, right? Di is 2, and don't be confused, with bi. There are like other things that can mean 2 as well, but in naming molecular compounds, we use di. Okay, like dioxide, and that's why I asked you to remember CO2, which is carbon dioxide, as well as being like the main greenhouse gas that is out there. Also, it's just like more straightforward. So di means 2, okay? And this is a typo. Tri is 3. Tetra is 4, like tetrahedral, right? Or other words that have tetra. Penta is 5, right? Hexa is 6. Your book, has so many typos. Hepta is 7. Octa is 8. And I was talking about octa in my other class, and I was looking for examples of octa, and then some students said octopus, and I was so happy with the example. So octa is 8, right? You also have like octane number in the gas, which means that it has like 8 carbons. So octa is 8. Nona is 9, and deca is 10. Deca is kind of like decade, right? So these are just like you should remember. You can think of words that they have like these prefixes in them, right? To help you memorize, but bottom line is that you should remember them, okay? So, and as I said, if you remember carbon dioxide, you remember that you should add IDE to the base name of non-metal, or like second element, second non-metal. And in general, remember that for molecular compounds, you have 2 non-metals. If you have a metal, that would be ionic compound, okay? So now, any questions about this before I go through some examples? Okay, can anyone tell me what is the name of CCl4? So what is the first prefix? What's up? Exactly. So we didn't write mono because it's just like 1 here, right? So we say carbon tetrahedral, chloride. Okay? What about BCl3?
Boron trichloride.
Exactly. Trichloride. And then boron is a metalloid, but still it can form a molecular compound. Okay, so remember that. SF6. Yes, sulfur. What was 6? Exactly. Hexafluoride. Okay. Are we good with this? Okay. And I'm going to wait on formula mass, but I'm going to start chapter 6, and next session I'm going to finish chapter 5. So one thing that is really important is in chemistry is the concept of mole, and the way that your book explained that is with the concept of nails. So if you want to buy nails in the store, I mean, except you want like 1 nail or 2 nails, usually you buy them by their pounds, right? So you don't go buy 1 nail or 2 nails, you know. And if you want to buy like 100 nails, what do you call it? I'm just a hardware store manager. They won't just like sit there count the nails for you, right? So what they do is that, I don't know, they use the concept of dozen, right? And dozen means 12. Dozen of anything is 12 of them. So what they do, depending on what size of nails they have, they measure the mass of 12 of them, okay, and record the number. So for instance, here in this specific example, the mass of 1 dozen nails is like 0.150 pound, okay? And then we know that 1 dozen consists of 12 nails. So when they measure the mass of specific nails that you want, so imagine they measure like 5 pounds. And by having these two conversion factors, you would know that how many nails exactly you are purchasing. Does that make sense? So now, if you consider this example and if you understood what it meant, chemists use the concept of mole. And specifically, 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. And this is the number that I asked you to remember, and we're going to deal with it during the rest of the semester. And sometimes the students think, because we're talking in a chemistry concept, mole is something related to chemistry, but that's not the case. If I say 1 mole of books, it would be this amount of books, 6.022 multiplied by 10 to the power of 23. And remember that, as I mentioned, it can be like for anything. It can be for books, coins, students, anything. It's a number. It's like dozen, right? When you say 1 dozen, it can be dozen of anything. It means 12 of that thing. Okay, now let's do the attendance, and also, as I said, answer the question about SI pass, that if you're fine with me knowing that you're going to SI pass, I'll gladly give you extra credits for that. And both for SI pass and tutoring, for each session that you attend, at least 1 hour, I add 5 points to your total grade in this class, which is out of 1,000.